I am going to do this question from section 4.3. It might be a different question number for you. I think they're randomly mixed up, um, but it should be the same sort of question. Numbers may change slightly. So the Smith family was one of the first to come to the U.S. They had 4 children. Assuming that the probability of a child being a girl is zero point 0.5, let's find the probability that the Smith family had at least 3 girls. And then after we do that, we'll deal with at most 3 girls. Okay, so first, we've got a binomial problem here. Let's identify that we're going to have 4 trials, so n is 4, and we're going to have that the probability of having a girl, a success, is 0.5, which means it's opposite failure of having a boy. In this case, failure would be a boy for the sake of the problem, not because boys are failures, but would be 1 minus zero point 0.5, or also 0.5. All right, but let's think about what it means to have at least 3 girls. At least 3 girls means we could have 3 girls or we could have 4 girls. All right, so 3 or 4. So really, we need to compute the binomial formula for 3 girls and for 4 girls and add the two probabilities together. All right, so what I have done is put on a page the binomial formula. Here it is. But let's write down our known values. We know n is 4. And I apologize when I draw on the screen. It's kind of slow, and so just bear with me. P is 0.5 and Q is 0.5. I know my point looks, I don't know, my Q looks kind of funny there. That is supposed to be a Q. Trying to make my points a little bigger there. Okay, now we said that at least 3 girls is 3 girls or 4 girls. So let's first compute x equals 3 in the formula. And then we will also compute, and I'll put it over here, x equals 4. And we'll add these two values together to get our probability. Okay, so n factorial will be 4 factorial on top. On the bottom, x factorial will be 3 factorial. I know my little factorial symbol looks almost like a 1. Just realize that is our little exclamation mark. And then n minus x will be 4 minus 3, or 1 factorial, which is really just 1. And then we want p 0.5, so I'll do 0.5 to the x power, which is 3 in this case, and q 0.5 to the n minus x, or 4 minus 3, or first power. All right, now let's just remember right here that 4 factorial means 4 times 3 times 2 times 1. And 3 factorial means 3 times 2 times 1. All right, and then 1 factorial is just 1, so I don't really need to write it again. But notice that what happens is 3 times 2 times 1 will cancel out, and this will end up being a 4. So I'm just going to sort of put it over here. We'll have 4 times really 0.5 to the 4th, because there's actually 4 0.5s there. Now, I'm going to leave that because I'll put them into my calculator all at once. But let's go to the second calculation of x equals 4. So if I put that into the formula, we'll have 4 factorial for n, and then 4 factorial n minus x factorial. So 4 factorial, 0 factorial, which again is 1. And it may not actually tell us that in the notes, so that's important to know. So really, this is 4 factorial. Over 4 factorial, it's 1. And then we'll have 0.5 to the x power, which in this case is 4. And we'll have 0.5 to the 4 minus 4, or 0.5 to the 0 power. And let me remind you from algebra that anything to the 0 power is 1. So really, this is a 1 right here. So that's a 1. And we have 0.5 to the 4th again, because that's going to be, the 0.5 to the 0 is going to be 1. So we can compute both of these in our calculator, and we will add them together. So I'll just go ahead and put a plus sign there. So we want to take these two and add them together, and that will give us our probability. And if I put that into the calculator, 4 times 0.5 to the 4th ends up being 0.25. And then 0.5 to the 4th ends up being 0.0625. And if I add both of those together, that ends up being 0.3125. Okay, so let's go to answering the second question. So our answer to this one is the probability 0.3125. Let me go back and we'll take a look at what our second question is. All right, now we're still going to use the same P, Q, and N values, but now we're looking at the probability of having at most 3 girls. Now let's think of what the words at most 3 girls means. We could have 0, we could have 1, we could have 2, and we could have 3. But we couldn't have anything more than 3. We couldn't have 4 girls in this particular instance. Okay, so we could do a computation of 0 girls, 1 girl, 2 girls, and 3 girls. But that's 4 different calculations we would have to do. Instead, let's do its complement, the idea that we had 4 girls, and of course we can use the law of complements and do 1 minus the probability of 4 girls, and that will give us the probability of at most 3 girls. So I'm going to go, oops, not to Excel. I'm going to go to, actually I might need to clear this. Let me see if it'll let me roll it down. Okay, I've got it down. We can't see the formula anymore, but I'll remind you of it as we go through. So I'm going to compute the probability of having 4 girls of x equals 4. And the truth is we have that up above. So we'll go get it here in a second. But then really what I want to do to get the probability of at most 3 is to take this probability and subtract it from 1 and use our complement rule. Now we do have the probability of x equals 4 from our previous computation. So again, let me see if I can roll it down this time. All right, so here it is. We did it up above. It was 0.0625. So really what we're doing here is 1 minus the probability of 0.0625. And I'll stick that in the calculator, and we will have this probability. And it is 0.9375. And that should do it. Hopefully that will help you through this problem, which is probably the most difficult of some of the probabilities that we have here.